Hello and good afternoon everyone. So here we are again with another tutorial which I'm going to teach you how to create a frequency distribution table in three ways. As you all are aware, we live in a world of data, and every day with our projects, with our research, we deal with huge amounts of data, and we do require some techniques in order to summarize our data. So one of them is a frequency distribution table, which it will help us to summarize our data and gives us a better vision towards that data. So we can understand easily which amount of data is related to this threshold, and either we have some outliers in our data and etc. other analyses. Also we can create some charts as well, like frequency curve and histograms using frequency distribution table as well. So without any wasting our time, we will use the Excel first, the manual method, as the first way to create our frequency distribution table. So I have my data here, which is the rainfall of a station. First, what I'm going to do is calculate the K index. The K is going to indicate how many classes do I need to have. 3.32 in logarithm 10 of count, first count of whole of my data here. Okay, and it counted. So I cannot have 6.66 classes, so either I have to choose 6 class or 7 class. So I'm going to choose 6. And now what I'm going to do is to calculate maximum, minimum, and the range of my data. The maximum is obvious. I have to calculate this one. The minimum as well. Minimum here. And the range of my data is going to be maximum minus minimum, which is about that. Now I have to calculate the I index, which is going to show me how much distance there is between the beginning and the end of each bean. So it's going to be R divided by K, the number of my classes. So this is the most important indices that I need to calculate at the beginning, and then I'm just for something count all of my data here. So okay, yeah. Now I'm going to create my frequency distribution table. So the first two is going to be beans. The second one is going to be xi, which is the center of each of our beans. The frequency, now the relative frequency, the cumulative frequency, and the relative cumulative frequency. So the first and the beginning of my first bean is going to be the minimum of my data. The second one, the end of the first bean, is going to be the beginning plus this R over I over here. So here it is. So I'm going to put dollar sign in order to, yep, and this is it. Yeah. So now what I'm going to do is to copy and paste all of this. So I can see my frequency distribution table is created, and the end of the last bean is equal to my maximum. Normally in this technique you have to achieve this. I mean, the end of the last bean is the maximum of your data, and the beginning of your first bean is going to be the minimum of your data. But in the rest two other techniques that I will tell you a little bit later, they don't have this. I mean, they have some random thresholds, they have some other algorithm that they use to create and calculate this amount of, I don't know, RK or whatever they want. But in this one, it actually covers the whole range of your data, but in the other techniques it actually covers much more than that. so it's up to you which one to use. So now I'm going to calculate the center of my beans divided by 2, and here it is. So, and for frequency, what I'm going to do is to use count ifs, count with 2 conditions. So the first one, the first input is going to be my data range, so I enter it. Then I will add the first condition, first double quotation, then I will add the data that are greater or equal to 17.1, again double quotation, and for the second condition I have to enter my data as well, so again comma double quotation, and the data that are smaller or equal to 53.91.667. So this was my first bean, the frequency of the first bean. So what I'm going to do is to put $sign before the rows and columns in order to not change them when I copy them into other cells. Simply I just have to change the range of each condition. So 53.9667, this one is going to be 19.773, and now 19.1255.2755. So, and this one and 238, the last one. So what I'm going to do now, after I calculated all the frequencies of the beans, I'm going to calculate the sum here. Sorry. So 51. The sum of all of my frequencies should be equal to count of all of my data. So here it is, and this indicates that my frequencies are calculated in a right way. So if sometime it was greater than that, it means that when you have put it this equal to in all of the beans, in all of the conditions of the beans, it means that sometimes one value is shared between two beans. I mean, it's like 164.3667 is both in this and in this. You just simply have to play with these equals, and then until you get the 51 amount correctly. And if you get less, it means that you didn't put equal to, and those amounts that are actually equal to the thresholds of the beans didn't calculate it and didn't belong to any of the beans, so you just have to simply put the equal to. So this was all about the frequency, and now relative frequency is going to be this one divided by 53, 51, and then $sign here, simply to just make it here, and then until here. So what I'm going to do is to sum, and then one of the indicators that if your frequency distribution table is right is that the sum of all of your relative frequencies is equal to 1. So, and then simply the cumulative frequency, which is 1 plus the before one, and the last cell in the column of the cumulative frequencies should be equal to the number of all data. And again, the same goes for the relative cumulative frequency. $signs here and here. So this one should be 1 as well. So if you have wondered how we can create histogram, you can easily just click these, whether each of you these that you want, usually relative frequency and relative cumulative frequency, and use this combo chart here as a way to actually create your frequency distribution table. As you can see here, it's somehow like that. The only thing that you need to do is that you have to, after creating the histogram, you have to delete the spaces between each columns in order to have an integrated histogram. So something like that, yes. So this was in the Excel method. The next one is going to be SPSS, or statistic packages for social sciences, which is somehow a little bit more easier. It doesn't have that much of a time, it doesn't require that much time. Simply, you just, after adding your data into a column, so you will go to visual binning here, add your data, continue, and this window should be open here. My data is rainfall, so simply I put it here. I go to make cut points here, and then I have 3 methods in order to create my beans. So the first one is width intervals, which I have to simply add the first cut point, the number of cut points, or the width, so it will automatically create it for me. The second one is going to be based on the percentiles of my data, and the third one is going to be based on mean and standard deviation. So I'm going to use the first one. I will add the 17.1 as the minimum at the first cut point. The number of cut points, which is somehow, optional until you hit the maximum of your data, or even if you hit below the maximum of your data, it still creates a bean that is greater, only it calculates the data, that values that are greater to the last cut point location. So you won't have that much of a problem, so it's simply up to you again, and this here will calculate the width amount. So it's just simply okay, make labels, and then you can see here are labels, okay, as well, and here we can have a visualization of where the actual cut points are, and somehow the histogram here, and it's executed. So I go to analyze here, descriptive statistics, frequencies, and I add the bean already this column that it actually happened to transform. Okay, here, and as you can see, my frequency distribution table is already created, and as you can see, it doesn't have the cumulative frequency itself. It does have the relative cumulative, but not the cumulative itself, so you have to calculate it manually. But otherwise, it's correct this using this method as well. It depends on you whether you want to waste too much time on it or no. You have to I don't know, calculate it fastly. So the third method, is going to be using Python code. So as a way to achieve this, I'm going to use pandas and NumPy in order to create my frequency distribution table. So I've already defined my file path and my sheet here. So what I'm going to do next is to call them, and I'm going to use the pandas with Excel function in order to do that. Excel, I'm going to call the file path, and then sheet name, which is equal to sheet again. So I've done the first thing. Now that the Excel file is already defined, what I'm going to do next is that use columns function in order to remove any leading or trailing spaces, so it will have to work without any errors. So df.columns is equal to df.columns. I have to strip them. Let's see, columns str. since I've done this, now what I'm going to do is that I have to actually call my data in. So you can easily print here df columns and see which one is your data. Okay, since this is not, wait a second, yeah, here. As you can see here, it already shows me that which of these is my data. In the Excel file, the first row is going to be the label of your data, which is better to actually put the name on it. So I have it here. What I'm going to do next is that I have to call my data. Data is equal to df data column drop na in order to remove any missing values, so I won't have any problems. So now that I've finally called my data into the code and Visual Studio Code, what I'm going to do is that I want to calculate my indices. So what I'm going to do is, first I'm going to calculate the length of my data, since I'm going to need it. Then the second one is going to be k, and 1 plus 3.3 np logarithm basis of 10, and yeah, here. So this was the k, which it indicates how many beans do I require. The next one is going to be data range, which is the maximum of my data minus the minimum of it. This data mean here. So this is the range of my data. Now what I'm going to do is calculate the width of my data. The width is going to be data range divided by k. So here. So now I've already calculated the necessary indices. The next one is going to be creating an array of bean edges starting from the minimum, and it goes until the maximum. So what I'm going to do is to define beans here. Then I will use numpy numpy library in order to arrange my beans from data minimum until data maximum. This is totally optional. Like I said, you can play and change the intervals. It's optional what you want, since I'm going to actually show you that how much difference it is there between covering the whole data and covering a little bit more of your data. I just added the amount of this plus a maximum of my data, so it covers a little bit more than that. So here it's going to be width, and then what I'm going to do is to add my labels of my frequency distribution table. So the labels are going to be here, and beans are here. So minus again, this one we'll have to repeat, int beans I plus 1. So now I have to calculate a loop for it. For I in range of my data, range of my length of my beans, is here minus 1. So now that I've already created my string labels for each of my classes. What I'm going to do next is to assign each number to a class interval. So what I'm going to do is to add frequency here. I will use pandas, cut my data, beams are equal to beams, labels, and include the lowest true in order to make sure that my lowest minimum of my data is already counted. Now what I'm going to do is to sort my values. So I'm going to value counts here and use the sort index here as well. So now my data has been sorted, the frequency of my data. So as the last thing, I have to create a data frame using pandas library. So yeah, PD data frame. I'm going to use a dictionary again. Here, class intervals are freq index. Then my frequency is going to be freq values. So now, since I've already created my data frame to store that frequency distribution in it, the last thing I'm going to calculate the proportion of each of my parts, like for example for the frequency, the relative frequency, and the cumulative relative frequency, and the rest of the stuff. So what I'm going to do is to call my table here. Let me just give it a space, table here, and it's going to be relative frequency is equal to table frequency divided by n. This is relative frequency, and then is going to be the cumulative frequency, which is table again, cumulative frequency, which is again using table frequency again. But here what I'm going to do is use CumSum function in order to calculate the cumulative frequency of my table. So now as the last column, what I'm going to do is to table again the cumulative relative frequency, frequency, which is again equal to table relative frequency here. Again, I have to calculate the CumSum or cumulative sum in order to have that. So now it's finished, and I can print my table here. Print table. Let's give it a CRC. So now, and again, what's the problem over here? Here I haven't typed it correctly. Yes. Now again, one more time. And here it is, my frequency distribution table. And as you can see here, it have already calculated all the necessary indices. It has a full detail that I require. It's so easy, you don't have to do it manually. So somehow it's time saving method. So, and this was the last method that I was going to show you how to create a frequency distribution table. I hope that you find this useful and practical in any of your researches and projects, and I hope you have a wonderful weekend. Goodbye until the next video.